Hello everyone, today we are going to find the arc length. So what is an arc length? Arc length is the length of part of a circle. And so this entire length right here would be called a circumference. And circumference is the length around the entire circle. And arc length is just a part of that circle, right? So we're trying to find this length, not the entire thing, but this length here. But automatically, given that this is 120 degrees, and just looking at this formation of how this is divided up, it looks like it's already like 120 degrees, right? It's already about a third. This is about a third of the entire circumference of a circle. So that already in my head, that's what I'm thinking. But let's go ahead and prove that it's actually a third. So the entire circle is 360 degrees. But the degrees that we're trying to find out is 120 degrees, right? So what I'm going to do is I'm going to divide the numerator and denominator by 120. 120 divided by 120 is 1. 360 divided by 120 is 3. So what I know is that this length is a third of this entire circumference, right? So if I find the entire circumference, multiply it by 1/3 or divide it by 3, then I'll get this arc length here. So circumference is c equals 2 pi r, and my r is 9. As you guys see right there, that's 9. So c is equal to 18 pi. So we have to now get a third, right? A third of 18 pi. So the arc length, we're going to call it the arc length, is going to be 18 pi divided by 3, or 18 pi times 1 over 3, which is the same thing. Which is going to be, arc length is going to be then 6 pi, right? 18 divided by 3 is 6 pi, or 6. So it's going to be 6 pi. So let's go ahead and we're going to write 6 pi. There's no pi, so we're going to times 3 point, oh, there is pi right there. 6 pi. And we're good. All right, now let's go ahead and look at this one. So this is 60 degrees. Automatically, I already know a 60 degrees is, I think, a sixth of 360 degrees. But we're trying to find this length right here. Okay, so how do we find this length? So I'm going to go 60 degrees over 360. That's going to be, divide the numerator by 60 and the denominator by 60, and I get 1 over 6, right? So what I know is that this length is a sixth of this entire circumference, okay? They already give me the circumference. So it says the circle with the circumference of 6. So if the entire circumference is 6, and this part is only a sixth of a 6, then it would be 1, right? So we're going to have 6, let's just say, I don't know, I have 1, 2, 3, 4, 5. So that's going to be 1, 2, 3, 4, 5, 6. What is 1/6 of this entire bar? That's going to be 1, right? Or you could do 6 times 1 over 6, and that's a 6 over 6, which is just 1. Okay, so my answer is going to be 1. 1. A sixth of a 6 is 1. Okay. This one is going to be, what is the central angle of the arc in degrees? Okay, well, let's take a look. So we already know that this time we're going to find this arc length, and we're going to call it x. So we know that the entire circumference is 20. So the circumference is 20. Circumference is 20. And the arc is the length of 4. Okay. So what I know, if I divide the numerator and the denominator by 4, it's going to be 1/5. So what I know is that this length right here is a fifth of this entire length. Okay. So this arc length is a fifth of this entire length, right? But this entire length is also 360 degrees. So if I find a fifth of 360 degrees, then I can find the central angle. So we're going to do 360 divided by 5, or you could do 360 times 1 over 5, whatever you find more comfortable. 360 divided by 50, 360 divided by, not 50, but 5 is 72. So it's going to be 72. Okay. So it's going to be 72 degrees. 72 degrees. And voila. Okay. So I hope that makes sense. Remember, this right here is a fifth, right? Like we did right here, of what? 360 degrees, because we're finding that the central angle, right? Which is in 360 degrees. Okay. All right, now let's take a look at this problem right here. So we got a circle with circumference 6. So this entire thing is 6. Don't let this confuse you, because I originally thought that this represented the arc was 6. No, the entire circle circumference is 6. With an arc with 340 central angle. So this right here is 340 central angle, and we're trying to find this red length right here. And so I'm just gonna do it with a different color. So that's red, and we're trying to find that entire length of that arc right there. So if this is 6, if this entire thing was 6 circumference, and we're given the 340 degrees, then what is this red length right here? So what I'm going to do is I'm going to just put 20 degrees here, because I know that 20 plus 340 is 360 degrees. So I want to see what is 340 in terms of a fraction. In terms of this entire circle, what is this red line a fraction? What fraction of this red line in terms of the entire circumference? So let me show you what I mean by that. So I know that this entire thing is 340 degrees, right? So this, or the red arc, is 340 degrees, and that's going to be in terms of 360 degrees, because the entire thing is 360 degrees. I divide the numerator and denominator by 10, and I get 34 over 36. And then I'm going to divide that top and denominator by 2, and I got 17 over 18. So what I know is that this red line is 17/18 of the circle. So this is 17/18 of a circle. And this right here, I'm going to put this in green. That is going to be 1/18 of the entire circle. So if we wanted to find this length, what I would do is 1/18 times 6, which is the entire length of the circle, or the circumference of the circle. But we don't want to find this right here. We don't want 1/18 of a circle. We want 17/18 of a circle. So how do I do that? I get 6, which is the entire circumference. So I do 6 times 17/18, right? Because we want to find 17/18 of, or we can just go like this if you want, of 6. So what is 17/18 of 6? And remember, of, when you translate into mathematical terms, it's usually multiplication. So what I'm going to do is I'm going to do 17 over 1. So 17 times 6, it's going to be 42, and it's going to be 102. 102 over 18. Okay, so I'm just going to make sure that that's what that is.